Welcome to Vishesh Educational Videos. In this video, I am explaining about 4 different types of APIs, that is create API, read API, write API and close API. If you are not subscribed to my channel, please subscribe to my channel. To get the notification of my new videos, please click the bell icon and please don't forget to like the video and please don't forget to share the video with your friends. So let me begin the explanation of each of these APIs in detail. First I will start with the create API. So the create API, the create system call is used to create a new file, particularly new regular file. Regular file means it can be a text file or a binary file. If you want to create the text file or a binary file, you can use this create API. And the create API prototype, you can see here the create API prototype contains 2 arguments. One is a path name and one is the mode. So these are the 2 arguments I have to give for this create API. Now we will discuss these arguments. So the first argument, path name, specifies the name of the files to be created. So when you want to create a file, you have to give the name to the file, right? And that name is specified using the path name argument. And the second argument specifies, that is mode. It is going to specify permission of a file to be accessed. What it's going to you can give a permission like read permission, write permission, execute permission, or you can give permissions like it should be accessed by a owner, or it can be accessed by a group of users, or it can be accessed by others, like that. You can give that type of permission details in the second argument, mode. And this create API can also be implemented using the open function. In Unix system programming, you know that open API is used to open the existing file, and also along with that, if a open API is also used to create a new file. You can use open API to create a new file, or you can use a create API to create a new file. So here I am implementing a open function, right? I'm implementing a create function using a open function. I'm implementing a create function using a open function. How it is? First, I'm defining the path name and the mode using a create API. You know that the 2 arguments for the create is path name and the mode. So first what I'm doing means I'm creating the file by defining the path name and the mode. After creating the file, I can use the open API to open the file that is created using the path name that is already defined. You can see there in open API I am giving the arguments. Actually in open API 3 arguments are there, the path name, and also along with that you can access mode. You can specify the access mode. Along with that you can specify the permission. Understood the difference, guys? In a create 2 arguments, but in open 3 arguments, right? So I can implement this create using the open also. It is possible. How I am doing this? I am defining the path name and the mode using a create function. Now I am opening using the same path name that is used while creating the file, right? Same path name I am using, but along with that I am using the one extra argument here, that is the access mode argument. That can be read argument. For example, access mode types are read only, write only, or read write only, right? I can use that 3 types of access modes along with others access modes like append, truncate, create, right? So this is one extra thing that is included in your open API along with the path name and the mode. Getting, guys? You can see there the access mode can be read only, write only, read write only, create, truncate. If you want to know more about this read write only, create and truncate, you can refer my video open APIs. The link is in the description. But so far you should understand that I can implement the create API using a open function. First I created a file using path name and the node. and I can use the same path name to open the file along with the mode and also along with the extra component access modes that is used in the Open API, right? If you have any doubts, please post your doubts in the comment section, guys, right? So next is a read API. The read function fetches a fixed size of block of data from a file referenced by a given file descriptor. What does it mean? In a simple words, read is used to read the data from the file. How read is going to find out the particular file? By using a file descriptor. File descriptor contains the inode number. So using that inode number, read can find out the file that it can be read, right? Understanding, guys? File descriptor is like address. It will find out the file, then it will start reading the data from the file. So what is the prototype of the read function? Here the read function contains 3 arguments here. First one is a file descriptor. You need a address of the file to read from the file. That's why first argument is a file descriptor and it is a integer value. Second argument is a buffer, and the third one is a size argument, right? So here 3 arguments are used for the read function. So now we will discuss these 3 arguments. The first argument is an integer. You know that file descriptor is an integer that refers to a open file. So file descriptor acts as an address to the file. Getting, guys? Once I know the address of the file, I can start reading. That's why file descriptor contains the integer value, that is the address of a file, that is the inode number of a file. The second argument, buffer, is the address of a buffer holding any data read, right? If you want to read from the file, the contents of the file are in the buffer. You know that you should read the contents, right? So buffer is the address of a buffer holding any data read. You can read from that buffer once you know the file descriptor. And the third argument specify how many bytes of data are to be read from the file. You have to tell how many bytes you are going to read from the file. That means, in other words, size. Bytes. Getting, guys? Getting? How many bytes you are going to read, that you have to tell in the third argument. Next is size data type. Is defined in the systype.register and should be the same as unsigned int. It is data type actually. Size underscore t is a data type, right? It is going to be used with the bytes because you have to tell how many number of bytes you are going to read. That means size of the read you have to tell. Getting, guys? And one more important thing here, there are several cases in which the number of bytes actually read is less than the amount requested. That means I request for 100 bytes, but I may not get all the 100 bytes sometimes. I may get only 30 bytes or 50 bytes. That is also possible. So the several cases are there in which the number of bytes actually read is less than the amount of requested. For example, you see here, when reading from a regular file, that is a text file, if the end of the file is reached before the requested number of bytes has been read, that means, for example, if 30 bytes remain until the end of the file and I am trying to read for 100 bytes, it is not going to return 100 bytes. It will return only 30 bytes because only 30 bytes is remaining. I am trying to read 100 bytes in a regular file, right? Only 30 bytes is remaining. I am trying to read 100 bytes. It is not going to return the 100 bytes, only 30 bytes, because it's only 30 bytes is remaining. That's why. When the next time we call the read, it will return 0, end of the file. That means only 30 bytes is there, it will return only 30 bytes. I'm requesting for 100 bytes, but it's returning only 30 bytes. Next time also, if you try to read for the 100 bytes, it will tell that it is reached the end of the file. Understanding, guys? I requested for 100 bytes, but 30 bytes is returned. Next time also, if you try, Next time if we call read, it will return 0. That means if file reached the end, I can't read it now. So this is the example. For number of bytes, actually read is less than the amount requested. I requested for 100, but 30 bytes returned. And also, when reading from a terminal device, normally up to one line is read at a time. This is also example of reading that is less than the requested. Suppose if I want to read 9 lines at a time, I can't. Normally up to one line I can read at a time. If I want to read 9 lines at a time, it's not possible. I requested for 9, but it is possible for only up to one line to read at a time. This is another example. And when reading from a network, obviously when you're reading from the internet, buffering within the network may cause less than the requested amount to be returned. Due to the packet loss, the amount of read you have requested may not, right? The amount of read you have requested may not come because of packet loss. So less data may arrive. That is also one example. And also when reading data from a pipe is a temporary buffer. Two processes can communicate by reading and writing to the same pipe. You will come to know more about the pipe in the upcoming sessions. So here, if the pipe contains the fewer bytes than requested, read will return only what it is available. Suppose if you want to read 100 bytes of data from the FIFO, and if it's only 30 bytes available, the FIFO will return only 30 bytes, not the 100 bytes. Because only the available data is 30, that's why. So what I am expecting, that is different, but what it is returning, that is different. In several cases it happens. Getting, guys? Next, write API. The write system call is used to write data into the file. Read is used to read from the file. Write is used to write the contents of the data into a file. The write function puts data to a file in the form of fixed block size referred by a given file descriptor. When reading the data also, I am reading the data in the form of fixed blocks. That means size is fixed. Here also, while writing the data also, I am writing the data in the form of fixed blocks. Some predefined size block. Here also, for writing also, I need a file descriptor because I need address of a file. For reading also, I need a file descriptor. Getting, guys? So what is the prototype of write? You can see here also I am using 3 arguments. One is a file descriptor, same as read. Another one is a buffer. You can see there always the pointer will be located. Buffer, the pointer will be located to the buffer. Star buff means what? Is a pointer. And next one is a size. Size t is the data type. Same arguments I am using here as read for write also. See, the first argument, obviously it is a file descriptor. It is the integer form. File descriptor is the integer that refers to an opened file. Once the file is opened using a file descriptor, I can read from the buffer. I can write to the buffer here. Buffer is the address of a buffer that contains data to be written. So this buffer contains the data that is to be written into the file. In the case of read, the buffer contains the data that is to be read from a file. Getting, guys? The third argument, size, specify how many bytes of data are in the buffer argument. That means it is going to tell how many bytes of data you are going to write into the file. There in read, it is going to tell how many bytes of data you are going to read from a file. Here it is going to tell how many bytes of data you are going to write into the file. Getting, guys? Same thing. Size underscore t is the attribute, data type of size. It will be in the form of bytes. See, the return value is usually equal to the number of bytes of data successfully written to the file. So it will return the size value. It is going to tell how much data, how much number of bytes is written to the file. That value is going to be returned. Size value is going to be returned. And one more important thing, If successful, write returns the number of bytes actually written. Yes, it will, you know that the return value is the actual number of bytes that are written if it is successful. You already know that, right? It's equal to the number of bytes of data that is successfully returned to a file. But if it's unsuccessful, it returns -1, that is negative value. Getting, guys? So next is close. Obviously, as the name suggests, the close system call is used to close the connection of a file from the process. In simple words, close API is used to close a file, right? The prototype of close is only file descriptor, only one argument, that is file descriptor. So if you want to close a file, you just need the address of the file, that is file descriptor, inode number you need, then you can easily close that file. So the close system call is used to terminate the connection to a file from a process. If a process wants to close the file, it can close it using this close system call array API. So what is the argument here? File descriptor is the argument. So see, if successful, if your file is successfully closed, it will return 0. If it is unable to close your file successfully, it returns -1. It is negative value. Obviously, the first the argument. What is the argument for the close? File descriptor. So it refers to a opened file. You know that any file can be accessed using the file descriptor that contains the inode number, right? So when a close function or when close API, when a close system call executes, right, it is going to free the unused file descriptor so that they can be reused to reference other files, right? Close function, it's going to free the unused file descriptors. When it frees the unused file descriptor, I can use them to reference other files. I can allocate for other files, right? This is important, very very important. Why? Because a process may open up to open max files at any time, and close function allows a process to reuse file descriptor to access more than open max files in the course of its execution. You know that we have some limits. If you want to know more about the limits, you can refer the video. The link is in the description. So the limits is going to tell, for example, maximum number of files that can be opened at a time, right? It is going to tell maximum number of files that is going to be opened at any time. So this close function, what it does means, when you use the unused file descriptor, it allows the process to reuse file descriptor to access more than open max files. Suppose think that 16 is the size of a open max, right? If you want to use 18, then, right, you can reuse the file descriptor using the close, because it is going to use the unused file descriptor, and you can use that extra 2 unused file descriptor if using a close. Getting, guys? That's why it is very important. You can use extra, right, files also. That's why, right? And the close function deallocates system resources. Obviously, when you close a file, whatever the resources that is allotted to the particular process or a file should be deallocated. Deallocated, right? You have to take it back, right? So the close function deallocates system resources like file table entry, memory buffer allocated, memory, right? All those things should be deallocated. Memory, table entry, those things, right? So hope you are understanding, guys. Suppose if you have any doubts, please post your doubts in the comment section. Thank you for watching the video.